So please mute yourself. Don't keep your this thing mic on, everyone. Balaji Borde. Okay, so this gradient del phi is equal to what I was discussing. We have to operate this operator, which okay plus dabba phi dabba y j bar plus dabba phi dabba z k bar. Okay, so this is the gradient of the function del phi is equal to dabba phi upon dabba x I bar. That formula we just got after operating del operator. So what are the properties of this gradient phi? Increase. If the value is negative, then we are going to get the values of decrease, value of decrease also. Okay, so it gives direction of the steepest slope. Okay, it gives the direction of the steepest slope, and its magnitude of del phi, that is mod of del phi, it gives the rate of fastest increase in that direction. So del phi, it will gives us the direction and its magnitude. Okay, see gradient, it gives the direction of the steepest slope, and its magnitude will gives us the rate of fastest increase in that direction. So its magnitude, it will gives us, its magnitude will gives us the maximum value of that change, maximum value of that increase or decrease. Okay, now here we are having one expression. Consider this we are going to use for finding scalar potential phi in our upcoming topic. For that we have considered del phi dot dr bar, which is equal to, now how I get this dr bar. So you just see, if I write my r bar as, yesterday we discussed how we are always considering our r bar as xi bar plus yj bar plus zk bar, right? Then I want dr bar. So dr bar is equal to dx I bar. So we have to get the differentials. Okay, plus dy j bar plus dz k bar, right? So that expression we have replaced here. Del phi dot dr bar is equal to first the gradient of the function phi and then dr bar. We take the dot product of the two. We know that I bar dot I bar is 1 and I bar dot j bar is equal to 0. And because of that, we will be getting dabba phi upon dabba x dx, and then dabba phi upon dabba x dy, dabba phi upon dabba x dz. Those two terms, they will be 0, plus then dabba phi upon dabba y j bar dot dx I bar. So j bar dot I bar will be 0. So we are remaining with dabba phi upon dabba y dy. Everyone, please mute yourself. Okay, so dabba phi upon dabba x, this dabba phi upon dabba z dz, and this whole expression in partial differentiation we discussed. This expression, what it represents? It represents the total differential of phi, right? You might be remembering that total derivative chain rule. In that we discussed the total differential as well. So, and this is the formula for the total differential, dabba phi dabba x dx plus dabba phi y, dabba phi upon dabba y dy plus dabba phi upon dabba z dz. Okay, it is equal to d phi. Therefore, I'm writing this expression like this: d phi is equal to del phi dot dr bar. Okay. Here, this expression we are going to use later on. Now, as we introduce this del operator, we must know its properties, how to use that. Okay. For that reason, here we are discussing this del operator. If you see, what is the del operator? We have discussed. It is a vector differential operator. Basically, it is containing derivatives. Dabba by dabba. Differential operators. It is containing dabba by dabba x, dabba by dabba y, dabba by dabba z. All these are differential operators, right? When we operate them on something, it will give us the derivative of that function. So being it is having the differential operators, it will satisfy all the properties of the derivative. Okay, therefore we are having del of u plus minus v. Now see, I haven't written here u bar v bar. Why? Because we evaluate the gradient of only scalar point functions. So one should not write at any point del u bar. This is not possible. This is not possible. We have to consider always del u, del v, or del phi. This u, v, phi, they must be scalar functions or scalar point functions. We cannot evaluate gradient, we cannot operate del operator simply on the vector point function. Okay, it should be operated on the scalar point function only. Okay, so everyone, please do keep in mind this thing. Uh, Therefore,
Sir,
we are, yes,
can you please explain why can't we use it on vectors?
we cannot operate it. No, see, because we are having vectors. No, we are having ijk. No, in that del is what? If I consider del u bar, it will be like this: del by del dabba by dabba x I cap plus dabba by dabba y j cap plus dabba by dabba z k cap, right? And into this is u bar. U bar is like, suppose u1 u1 I cap, okay, u1 I cap plus u2 j cap plus u3 k cap. Now we have discussed, if we are having the two vectors with us, then between those two we must have either dot product or the cross product. Do you understand? To simplify it.
Yes, sir.
But here we don't have anything, no. So how we can proceed further? It will remain as it is. We can't operate this differential operator on this entire vector, because then what to do with I cap into I cap? This operation is not valid. Do you agree with me?
Yes, sir.
And therefore gradient of del of vector point function never be evaluated. Okay, it will be operated only on scalar point function. Fine. And now these are the deductions, means we are discussing the properties of the del operator so that we can use it further. So del of u plus minus v equal to del u plus minus del v. Here we have to apply the product rule of derivative. So u del v plus v del u, the quotient rule, same. So whatever the rule we discussed for the derivative, same rules are applicable. Only the change is here that we will discuss. Now, when a is constant, then del of au is equal to a into del u. Del of f of u, I will derive it here down. Okay, del of f of u equal to f dash of u into del u. Then del dot del. Okay, so if I consider the del dot product of this operator, then uh, I we are getting dabba by dabba x of dabba by dabba x, because I bar dot I bar. So it will gives me dabba square upon dabba x square. Remaining two terms will be 0, then plus dabba by dabba y of dabba by dabba x. Okay, into, and then we are going to have j bar dot I bar. So it will be 0. Then dabba by dabba y or dabba by dabba y into, so it will be dabba square upon of means of, because we are going to operate here, means of. So dabba square upon dabba y square, similarly plus dabba square upon dabba z square, and this particular term it will be represented as del square. Okay, so dabba square upon dabba x square plus dabba square upon dabba y square plus dabba square upon dabba z square, it will be represented by del square. And del raised to 4 can be written as del square into del square. Okay, it is not like del raised to 4 can be written as del square dot del square. It is not possible, because what is del square? Del square is the scalar quantity. We don't see here ijk, right? Therefore, for writing del raised to 4, it should be written as del square into del square. Means then whatever function will be in front of this, we have to operate del square first on that function. We have to operate del square successively twice. First del square, then second del square. Likewise. Then gradient of phi, this gradient of phi, it defines normal to the tangent plane of phi. Okay, so del phi, because it is the direction of maximum change in that function, and the maximum change will always occurs along the normal. This del phi, it defines normal to the surface phi. Tangent plane means at that point we need to observe. No, so in the three dimension, the single point, the line we cannot observe, therefore we are observing the point plane like this, we are obtaining the plane like this, and to this plane at this point we are getting the normal. That normal will be del phi. If my phi is the surface, then del phi will gives us the normal to the surface phi at any given particular point, x1 y1 z1. Likewise, okay, x1 y1 z1. Likewise, so gradient will gives us normal to the surface phi. Okay, gradient will gives us normal to the surface phi. Now as I discussed, we want to discuss the proof of this uh, deduction, that del of f of u is equal to f dash of u into del u. How it is that we want to discuss. So I will add the new page here. See, we are having the deduction del of f of u is equal to f dash of u into del u. It is like partial derivative only. You have we have discussed, whenever our function is a composite function, then how we evaluate the derivative? First of all, ordinary derivative of the function f, and then the partial derivative. So here partial derivative is this, like is the operator that we have to evaluate. So gradient of that function u we are supposed to evaluate. How it will be done? If I consider the LHS, del of f of u is equal to, then what it will be? First of all, I will write down the del operator. So dabba by dabba x I cap plus dabba by dabba y j cap plus dabba by dabba z k cap. Unless and until it is mentioned in the example, we are always going to consider del operator in this three dimension. Okay, I, j, k only we are going to consider, not in two dimension. If it is mentioned, then only we are going to consider the two dimension. Now we have to operate this f of u is a scalar point function. We have to operate each of the operator on this f of u, so that we will be having the expression of this type: dabba by dabba x of f of u I cap plus dabba by dabba y into f dabba by dabba y of f of u j cap plus dabba by dabba z of f of u k cap, right? This is equal to, now partial derivative of f of u will be what? F dash of u, and u is a function of x, y, z again, so it will be dabba u upon dabba x, composite function I cap plus With respect to y also, it will be f dash of u into dabba u upon dabba y j cap plus f dash of u into dabba u upon dabba z k cap. Okay, f dash of u is common. Take it outside. So in the bracket we are remaining with dabba u upon dabba x I cap plus dabba u upon dabba y j cap plus dabba u upon dabba z k cap. Okay, this is equal to, now how can I write this expression? So I can write it as dabba by dabba x of I cap plus dabba by dabba y of j cap plus dabba by dabba z of k cap, and we have to operate it on u, so that this can be written as f dash of u into f dash of u into this. We can write as this expression, we can replace it by the del operator del, and u will be as it is. So we got del of f of u is equal to f dash of u into del u. So this is very important result. We are going to use it frequently in the upcoming topics. Okay. And if you don't remember, you can easily derive like this. Do you understand this? Any doubt in this derivation? Everyone understood this?
Yes, sir.
Yes, sir.
Okay, fine. So we were discussing the deductions we discussed. Okay. Now the directional derivative. What is happening when we evaluate the ordinary derivative with respect to x? Then just I'm telling here, when we evaluate dy by dx, when we evaluate dy by dx, means we are evaluating derivative in the direction of x-axis. Okay, this is the derivative in the direction of x-axis. When our function is a function of more than one variable, let's say u equal to f of xy, then what we do, or f of xyz if I consider, then what we do, we evaluate the partial derivative of u with respect to x. So it will be in the direction of x-axis. Then dabba u upon dabba y, it will be direct in the direction of y-axis. Then dabba u upon dabba z, dabba u upon dabba z, it will be in the direction of z-axis, right? So along these axes only we are evaluating. But if I consider my three-dimensional coordinate system, for example, and if I consider any arbitrary vector, if I consider any arbitrary vector, let's say u bar, and in the direction of this u bar, if I have to evaluate the derivative, suppose my u bar is equal to u1 I cap plus u2 j cap plus u3 k cap. Now, what I want to do, I want to evaluate the derivative of that function in this arbitrary direction. It is not exactly along x-axis, y-axis, and z-axis. Okay, it is somewhere in between like this. So that direction, along that direction, we need to evaluate our directional derivative. Then how to do? So that derivative will be evaluated using this formula, that is gradient. The slope of that function, how much is the slope of that function in the given direction? Okay, it is the steepest slope. So basically it is used in constructing the roads. Whenever any sharp turn is there, obviously there you might have observed the road is slightly slanting. Okay, it is not exactly flat, otherwise our bikes will get skid, right? There is always a slope. So it is in any direction. It is not like that it is always in XYZ direction. It is in the arbitrary direction. So that can be evaluated from this. How much the slope should be there in that particular direction so that vehicle will not the leave road or it will not get skid. Fine. So this is the formula. The directional derivative, it is the derivative of the scalar point function in any given direction u bar. Okay, in the direction of the vector u bar. The direction of the vector u bar will be what?
U upon norm of a u.
Yes.
U upon norm of u.
Means unit vector, no?
Yes, sir.
U cap. So direction, yesterday we discussed, right? The direction of the any vector is the unit vector of that vector, right? It will gives us the direction. Unit vector will gives us the direction of that vector, right? And therefore, what we are doing, we are considering the gradient of that particular function, its dot product with the unit vector along unit vector of the vector along which we wish to obtain the derivative. Okay, so as this direction is arbitrary and given by us, it is called as the directional derivative. Okay, and this is the formula del phi dot u cap. The dot product will be evaluated. Now, regarding this, there are remarks. What if phi is a surface that already we discussed above, then del phi is representing what? Normal to the tangent plane at that particular point. Okay, if phi is a surface, then del phi is normal to the tangent plane, and the directional derivative of given scalar point function phi is always maximum in the direction of its normal. Okay, and what is the normal of the any given surface? It is del phi. Normal of the given surface is del phi, and we discuss here in the gradient. See, I will show that thing again. So gradient vector, it can be interpreted as direction and rate of fastest increase. Okay, so we are going to get the directional derivative maximum in the direction of its gradient, that is del phi, and the maximum magnitude is maximum value is the magnitude of del phi. Maximum value of the directional derivative is magnitude of the del phi. That thing only again I have mentioned for the directional derivative. So directional derivative of phi is maximum in the direction of del phi, and maximum magnitude is norm of del phi or mod of del phi, you can say. So these are the important things here to note down, and these remarks we require again and again while solving examples on directional derivative. Now, as I discussed, we are going to consider any arbitrary direction along the vector u bar. So what kind of directions we are going to refer to in this particular module? So there are total 5 directions that we are going to consider, along which we are going to evaluate the directional derivative. What are those? Firstly, it is along the vector u bar itself. Means in the example, they will give the direction like this. Okay, they will state the direction in this way along the vector u bar, then from the point towards the point, means from P to Q, this. So from the point towards the point Q, then along the normal to the surface psi of xyz at Q, this Q is the point along the normal to the surface. Now what must be the normal to the surface psi at point Q? It is del psi at point Q. Okay, normal to the surface psi will be del psi. Then along the tangent vector to the curve r bar equal to xi bar plus yj bar plus zk bar at p is equal to a or xyz. Now we know yesterday itself we discussed what is the tangent vector to the any given curve by r bar. What is the tangent vector?
Sir.
Take partial derivative.
Sorry,
Take partial derivative.
why partial derivative?
Sir, because means in I cap we have to take dx upon tab x upon tab x, like that we can.
No, see, in this module, no, here r bar, it is always like a function of one variable only. Although you see here r bar equal to xi bar plus yj bar plus zk bar. Yesterday you might have noticed that I wrote the r bar t as x of t I cap plus y of t j cap plus z of t k cap. Okay, and in short, it can be written like this: r bar equal to xi bar plus yj bar plus zk bar. So this is always there. Equation of the curve will be given in terms of one parameter t only, and because of which we are getting our t bar as dr bar upon dt. Have we written this thing yesterday? Tangent
Yes, sir.
vector.
Yes, sir.
Okay, so no need to evaluate the partial derivatives. The tangent vector will be given by this formula dr bar upon dt. Okay, and this t is equal to a. So likewise, you have to replace the value of t to get that particular vector. Otherwise, it will be in terms of t, the variable tangent vector. We want here particular tangent vector to get the directional derivative, right? If suppose we have been given the point x, y, z, then from this equation like x of t, y of t, z of t, we need to obtain the value of t ultimately. Okay, we can't replace the values of x, y, z directly. You consider any relation either x, y, z, then for from that we need to get the value of t, like that. While solving example, you will come to know. Here just I am discussing that in the problem we are going to consider these five directions. Okay, if additional direction will be the, if any additional direction will be there, I will let you know later on, but right now there are only these five directions which we are going to consider. Then along the line, now this equation, anyone remember this equation is in which form? Do you know the name of this form?
Sir,
Yes,
in the second point, I couldn't understand what exactly is point Q.
towards the point Q.
Yeah, like what is point Q here?
Point Q means it is a point na, in three dimensions. See, like means suppose from some point you need to start to obtain the directional derivative. No, vector, because vector we want to represent. Vector is having star initial point and the end point. Do you agree with me?
Yes.
Okay, so our initial point will be P and end point will be Q. So we wish to, if we wish to evaluate the directional derivative at the point P, okay, del phi at the del phi dot u cap, del phi at P, okay, and its directional derivative at the point P and towards the point Q. So this vector will represent u bar
Okay,
and its
understood.
direction we need to calculate. So this is like towards the point.
Okay, sir.
Do you understand?
Yes, thank you.
Okay. Any question, anyone? Okay, so whatever this form I have written here, equation of the line. So it is, you can consider the slope point form in 3D that way. In 2D, actually, it is like this. Okay, slope point form. But here in 3D, it is called as, this form is called as equation of line, equation of line in symmetrical form, equation of line in symmetrical form. Okay, now when I write like this, then what it gives us means this line pass through point, let's say Q alpha beta gamma with DRS. Now everyone is aware of the DRS, is it? Direction ratios. Have you studied or not? Direction ratios, are you not aware of direction ratios, direction cosines? You know, learn this thing, no?
Sir, I can't properly recall it. Can you please just revise for us?
This is the for that form. Direction ratios, they will what? They will gives us the direction of that line. Okay, in three-dimensional coordinate system where that line is, and those direction cosines LMN, they are the angles made by the line with x-axis, y-axis, and the z-axis. Do you remember that?
Yes, sir. Now I remember.
See, means that's a page. Okay. He see here, whatever, suppose you treat this as a line, then you might be remembering angle made with the x-axis, we are denoting it by the alpha. Okay, angle made with the y-axis, we are denoting it by beta, and angle made with the z-axis by that line, we are denoting it as gamma. And then we are writing the direction cosines, L as cos alpha, M as cos beta, n as cos gamma, right? So these angles, they will give us what is the exact position of that line in the three-dimensional coordinate system. And as they are defined in terms of cosine, and they defines the direction of the line, therefore they are cosine. Any numbers parallel to these three, any number, they are scalar multiple of these three numbers, they are called as the direction ratios. Okay, so ABC, they are scalar multiple of LMN. Okay, so L can be written as some K1 into A, then M can be written as some K2 into B, and N can be written as some K3 into C. So this A, B, C, they defines the direction ratios. LMN, they are called as direction cosines. Is it?
Sir, are ABC here unit vectors?
No, no. They are not vectors, they are numbers, scalars. And they are scalar multiple of the direction cosines. So these are ABC, they are any three numbers. Likewise, scalar multiple of element.
So are elements the smallest possible values here?
Element are,
Means are elements smallest possible values and ABC are their multiples like this or the vice versa?
yes, exactly. See here, and means if you evaluate L square plus M square plus N square, then its square root is equal to 1 always. So you need to see right now for this particular case, you just keep it in mind this thing that ABC, they are the direction ratios, and element, they are the direction cosines. Okay, later on in the offline class, I will explain it if you want it again. Fine.
Okay, sir.
Hmm. So this is the equation of the line in the symmetrical form. And what is the important thing to keep in mind here? This is the standard form of the line which is given to us. And in this, coefficients of x, y, z. See, purposefully I have written the coefficient as 1, 1, 1. So unless and until we will not get the coefficient of x, y, z as 1, 1, 1, we cannot treat the numbers in the denominator as direction ratios. So when you make the coefficients of x, y, z as 1, 1, 1, after that, whatever numbers you will get in the denominator, those numbers, they will be treated as direction ratios. Okay, those numbers, they are treated as direction ratios, otherwise not. So these are the 5 cases along which we are going to evaluate our directional derivative. So this is the theory regarding gradient and the directional derivatives. So we will go for solving the examples. So I will discuss here simple example how to evaluate the gradient for the given function. And then we will go to direction ratios. Okay, examples. First, if phi is equal to xy plus yz plus zx, then find grad phi at 1 minus 1 1. Okay, then find grad phi at 1 minus 1 1. Now grad phi is what? Grad phi means gradient of phi, which is denoted as del phi. We know the del operator, it is dabba by dabba x I cap plus dabba by dabba y j cap plus dabba by dabba z k cap. Okay, of phi. So this is equal to dabba phi upon dabba x I cap plus dabba phi upon dabba y j cap plus dabba phi upon dabba z k cap. Dabba phi upon dabba x I cap plus dabba phi upon dabba y j cap plus dabba phi upon dabba z k cap. Therefore, now what is our phi? Our phi is xy plus yz plus zx. Okay, so here I will write del phi only. So del phi is equal to, now what we have to do, we have to differentiate our function phi, which is a scalar function, with respect to x partially. So we will be getting dabba phi upon dabba x as y plus z I cap, right? Yz, its derivative will be 0. Here we will be remaining with y. The second term yz, its derivative partially with respect to x will be 0. That I have not written. Then dabba partial derivative of zx with respect to x will be z. Therefore, we are getting here y plus z, and this I cap will be as it is plus. Now differentiate phi partially with respect to y. What do we get here? So it will
X
be
plus Z.
x plus z j cap, and then x
I
plus
plus X
y
K cap.
k cap. Okay, so this is how we evaluated the del phi, and now evaluate the del phi value at the point 1 minus 1 1, means we have to replace x by 1, y by minus 1, and z by 1. So what do we get here? Minus 1 plus 1 I cap plus 1 plus 1 j cap plus 1 minus 1 k cap. If we simplify it further, it will be 0 I cap plus 2 j cap plus 0 k cap. So it is simply 2 j cap. Means the direction of the maximum change, it is y axis, because here I got del phi at 1 minus 1 1, it is 2 j cap, and we know that j cap is what? It is the direction of y axis, right? So whatever the phi surface is given, its maximum change, okay, or steepest increase at the point 1 minus 1 will be given in the direction of y-axis. Okay, that steepest change will be given in the direction of y-axis. I don't know what means that a surface exactly. In GeoGebra, you can today I will share that PPT for the fifth assignment. You have to perform. You have to solve at your own. Okay, so this is X, Y, Z axis. Then the steepest change direction will be the Y axis. Okay, this way, maximum increase. And this is how we are going to evaluate gradient of that function phi. Okay, gradient of that function phi. And what will be the maximum change, maximum magnitude? Okay, so this is the direction of maximum change. This is the direction of steepest change or maximum change, you can say maximum change and maximum magnitude and maximum magnitude is its modulus mod of del phi at that point 1 minus 1 1, which is equal to what? Square root of, being vector, del phi is a vector, so the modulus will be 0 square plus 2 square plus 0 square, which is equal to 4. So this will be the maximum magnitude. Likewise, we are going to evaluate it. Maximum magnitude of that steepest change is 4.
Sir, two.
Yes. Oh, sorry,
Sir,
2.
answer.
Yes, yes, yes. It is a square root. I forget. Sorry. It is 2. The maximum change is 2. Correct. So this way, we are going to evaluate the gradient of the function phi. Now, I will give you the another example based on the gradient. See, if we are having the two surfaces and if we want to uh, find angle between those two surfaces at a given point, then how it will be evaluated, that we are going to see. Second example, find angle between two surfaces. Find angle between two surfaces x square plus y square plus z square equal to 29. X square plus y square plus z square equal to 29, and the second surface is x square plus y square plus z square plus 4x minus 6y plus 8z is equal to 47, is equal to 47 at the point 4 minus 3 2, at the point 4 minus 3 2. Both are the spheres, x square plus y square plus z square equal to 29. This one is also a sphere, and x square plus y square plus z square plus 4x minus 6y plus 8z equal to 47. This is also a sphere, and we wish to obtain angle between these two surfaces. Now, what do we know? First of all, angle between two surfaces. Angle between two surfaces is equal to angle between normals, angle between their normals, angle between their normals to the tangent plane, to the tangent plane. So this is the property, because angle will be evaluated between two lines only, right? And not the surfaces. So to obtain the angle between two surfaces, first of all, we need to obtain normal to the tangent plane at that particular point. Okay, normals to the tangent planes at that particular tangent plane of both the surfaces at that particular point. And then by using the formula, we are going to obtain uh, angle between those two surfaces. Okay, so first of all, I am going to consider first surface as phi. So let phi is equal to x square plus y square plus z square
Sir,
minus, yes.
sir, I didn't understand the statement angle between their normals to the tangent.
Okay, see, angle between means surface is a scalar equation, right?
Hmm.
Because if I am having one sphere here like this and another sphere here, suppose whatever, that's another second sphere, it is there. Now how do I evaluate angle between these two surfaces? It is not possible. So angle between two surfaces means what? You consider a point, uh, you consider the point. Now here we have given one point, suppose this is a point of intersection of the two surfaces. Then what I am going to do, I am going to obtain the tangent plane to the one sphere at this particular point. Okay, then I am going to consider the tangent plane to the second sphere at that particular point. Then I am going to obtain, from this point I am going to obtain normal to the second sphere, and from this point I am going to obtain normal to the first sphere. Then how much will be the angle between these two normals? How much
Sir,
will
but
be? Hmm.
why don't we directly evaluate the tangents because we know the point and then we just find the angle between both the tangents? Does
No,
that not
no.
work?
See how you are going to evaluate tangent to the surface.
Sir, I'm sorry, I'm not familiar with spheres, that's why.
No, no, because yeah, see, in the vector, no, you can evaluate tangent either to the curve, right?
Hmm.
Its equation means if my curve is r bar, then t bar will be evaluated as dr bar upon dt. So to the curve, tangent will be evaluated like this. Now,
Okay.
whenever talk about the surface, to the surface, we cannot draw the tangent line. We need to consider the tangent plane. Okay,
Okay,
so
understood.
basically we are trying to obtain the angle between tangent planes. But again the
Okay.
same thing, plane is having the equation, it is not a vector.
Hmm.
So to obtain the angle between tangent planes, what we are doing? We are obtaining angle between normals to that tangent plane,
Okay.
and
Yes, sir.
ultimately it will give us angle between those two surfaces. Is it okay now?
Okay. Yes, sir,
Oh,
understood. Thank you.
fine, thank you. Fine. So what we are trying to do here, now I am denoting these surfaces by the notations phi and psi. Our second sphere is x square plus y square plus z square. Okay. Then plus 4x minus 6y plus 8z minus 47 equal to 0. Minus 47 equal to 0. Now I wish to obtain the normals to these surfaces. Okay, so normals to the tangent planes at 4 minus 3 2 the surfaces phi and psi are given by del phi. So del phi is equal to what it is? Dabba phi upon dabba x I cap plus. Now you can use formula directly. No need to write down del operator separately and then do the to operate that operator on phi. You can write down this formula directly. So that what del phi we are going to get 2x I cap 2y j cap. Okay, complete whole this phi I am differentiating with respect to x, and out of it I am getting dabba phi dabba x simply 2x. Then dabba phi upon dabba y as 2y. Then 2z k cap, right? And this we are supposed to evaluate at the point 4 minus 3 2. So that what must be our del phi? So it is 8 I cap minus 6 j cap plus 4 k cap. So see, this is the normal to the surface phi at point 4 minus 3 2. Similarly, we have to evaluate del psi now. So what must be del psi? Del psi is equal to 2x minus or plus 2x plus 4 I cap plus 2y. Okay, 2y minus 6 j cap. See, this is our surface. So I differentiated psi with respect to x, with respect to y. Now with respect to z, I am differentiating. So it is 2z plus 8 k cap. 2z plus 8 k cap. Okay. Now evaluate the value of del psi again at that point 4 minus 3 2. So which will be equal to 8 plus 4, so 12 I cap,
I cap minus 12 j cap plus 12 k cap.
12 j cap plus 12 k cap. Is it?
Yes, sir.
Okay. Now, what we have to do, take the obtain the angle between these two normals. Therefore, angle between, see, I will call this as N1 and N2 so that to write down it will be easy for me. N1 and N2. N1 means normal to the surface phi, normal to the surface psi. So angle between normals N1 and N2 is given by angle between normals N1 and N2 is given by theta is equal to
Cos inverse of
cos
N1 dot N2 upon mod N1 mod N2.
mod N1 into mod N2. Likewise. Okay, please do evaluate this, everyone. You are having those two vectors above. 8 I cap minus 6 j cap plus 4 k cap, then 12 I cap minus 12 j cap plus 12 k cap. Okay, evaluate this and tell me what angle you are getting.
So
Sir,
Yes,
I'm getting
why didn't we write
15.17
norm?
degree.
get the lowest fraction of that.
Means sir in degrees I am getting 15.17.
Anna, I am asking on your calculator, there is a key to A by B key or C to D key on new calculators. Okay, a decimal to that Q by P form, P by Q form, that key is there. I just want the
Sir,
insight. Yes,
There should be norm, no? Means while writing vectors, we write norm means, instead of modulus, no?
Okay. Anyone evaluated this numerator and denominator?
Point 0.965 means inside cos inverse, I'm getting 0.965.
It's still 15.42 degrees.
Here, whatever value I'm having, no, it is 19 upon 29. Just correct. Just let me know whether it is correct. Cos inverse of 19 upon 29. Likewise, is it correct?
Sir,
Is it?
no, sir, it is coming 0.964.
Yes, sir. I'm also getting 0.965.
Cos inverse of point like this.
965.
Okay, ठीक है. Then you keep answer like this. Not an issue. But always means as far as possible, try to express it in fraction, not decimal. So this is how we can evaluate the angle between two surfaces. Everyone understood?
Yes, sir.
So angle between two surfaces is the angle between their normals to the tangent plane. Here I missed the word plane. Sorry. Tangent plane. Okay. Now we will take the example on directional derivative. What I will do in the one example, I will consider um, more directions so that it will be easy for us not to refer to the question again and again. So take the example, find the directional derivative of I'm writing here like dd, okay, but this is directional derivative of phi equal to xy square plus yz cube at 1 minus 1 1. First, along the vector I cap plus 2j cap plus 2k cap. Then second, towards the point towards the point 2 1 minus 1. Third, along the direction normal to the surface normal to the surface x square plus y square plus z square equal to 9 at 1 2 2. Then along the line parallel to in the direction parallel to in the direction parallel to the line, in the direction parallel to the line x minus 1 is equal to 3 minus y is equal to 2z. In the direction parallel to the line x minus 1 equal to 3 minus y equal to 2z. Right? Along the tangent vector, along the tangent vector to the curve, along the tangent vector to the curve, r bar is equal to t I cap plus 2t minus 1 j cap plus t square k cap at t is equal to 1, at t is equal to 1. So these are the directions along which we wish to find directional derivative of this function phi. Okay, phi is xy square plus yz cube. So let us start with the solution. Given scalar point function is phi is equal to xy square plus yz cube, right? And point P is P equal to 1 minus 1 1. Okay, these are the given thing. Now we wish to find the directional derivative of this function, and for that, first of all, we will be requiring the grad phi. Now del phi is equal to, so it is common to all the phi cases, that's why we keep it evaluated, and we will use it wherever we will require it. Okay, so now del phi is equal to
xi cap
formula.
plus
Formula you always have to note down. Okay, don't forget to write down the formula, because if your derivative goes wrong by mistake, then at least for the formula you will get the marks. Now dabba phi upon dabba x, it will be
xi
y,
cap
y square I cap plus dabba phi upon dabba y will be 2xy plus z cube j cap plus dabba phi upon dabba z will be 3yz square k cap. Am I right?
yes sir.
Everyone got the same gradient, is it?
Yes, sir.
Okay. Only Himanshu, Gangras, and Pal they are answering. What about others? This is equal to 1 means now we are evaluating value of this del phi at 1 minus 1 1. So replace x by 1, y by minus 1, and z by 1. Therefore this will be I cap plus now minus 2 plus 1, so minus, okay, minus j cap
Minus
and
3 k cap
minus 3 k cap. So this is what our del phi is, which we are going to use everywhere. Now we are going to consider first to find directional derivative. So directional derivative is given by del phi at point 1 minus 1 1 dot with u cap. Okay, del phi at point 1 minus 1 dot with u cap. So this is the formula, and now we are going to consider all the five cases one by one. First, along the vector along the vector u bar is equal to, so vector, whenever they will say vector, you have to consider it as u bar, and then we need to obtain its
U
unit
cap
vector. Okay, it is I cap plus 2j cap
2j cap
plus
plus 2k
2k
cap
cap.
upon 3.
Yes, its direction is, purposefully I am writing direction all the time. Just you should not forget what is the direction of any vector for that reason. Okay, so u cap is equal to u bar divided by norm of u bar, which is equal to I cap plus 2j cap plus 3k cap divided by under square root 1 plus 4 plus 9, which is equal to
Sir,
1 plus 4 plus 4, sorry, not 9. And square root of 9 is 3. Therefore, we are going to get u cap as 1 by 3 into I cap plus 2j cap plus 3k cap. Therefore, directional derivative of the given function
Sir,
at this, yes,
you in U bar you have written 3k cap, but it should
hmm,
be 2k cap.
correct. Okay, so directional derivative is equal to del phi at point 1 minus 1 1 dot with u cap. Okay, for this particular case, so it is equal to I cap minus j cap minus 3k cap dot with 1 by 3 into I cap plus 2j cap plus 2k cap. Take the dot product. 1 by 3 is a scalar. Take it outside and do the evaluate this dot product component wise,
Minus 7
means
by 3.
multiply coefficients of I, then plus jj plus kk. So it will be 1 into 1, 1. Then plus minus 1 into 2, it is minus 2, plus minus 3 into minus 2, which is minus 6. Minus 8 plus 1 is minus 7. So this will be minus 7 by 3. So directional derivative of the scalar point function, given function, along the vector I bar plus 2j bar plus 2k bar, it is minus 7 by 3. So this much is the slope in that direction for the given function. This is the first case. Now second, towards the point q is equal to 2 1 minus 1. Therefore, directional derivative of phi from the point p 1 minus 1 1 to the point q 2 1 minus 1 2 1 minus 1 is along the vector, is to obtain along the vector along the vector qp bar. Yesterday we discussed how to evaluate the QP bar. So which is given by 2 minus 1 I cap plus 1 minus minus plus 1 J cap plus minus 1 minus 1 K cap, which is equal to I cap plus 2J cap minus 2K cap. Am I right?
Yes, sir.
This is our QP bar. Now, along the direction of this vector QP bar, we wish to evaluate directional derivative. So we will consider this vector as U bar. So let U bar is equal to I cap plus 2J cap minus 2K cap. And therefore, the directional derivative. Now I am going to evaluate the unit vector there itself. That was the first case. That's why I evaluated it separately. Now you are knowing direction is nothing but the unit vector of that given vector. So directional derivative is equal to del phi at, don't forget to
Sir, I
write.
have a doubt.
Yes.
Sir, while calculating QP bar, we used to do final minus initial, that is P minus Q. So you did
Ah,
initial
okay,
minus
okay.
final.
Fine, fine.
So
PQ bar, I have to write. I have written QP bar. Then
okay,
PQ
sir.
bar is this. Okay, you do the further calculation.
Pi by 3.
Okay, what is the value? So here, first of all, we have to
Pi
replace
by
the
3.
values. Wait, I have to replace the del phi first. It is I cap minus j cap minus 3k cap dot with 1 by 3, because again we are having the numbers 1 square plus 2 square plus minus 2 square. So it will be root 9, which is 3 again. So 1 by 3 into I cap plus 2j cap minus 2k cap. If we simplify this, 1 by 3 into 1 minus 2 minus minus plus 6. 7 minus 2 is 5 by 3. Is it?
Yes, sir.
Okay. Now next we had along the direction normal to the surface, right? See, third one is along the direction normal to the surface, which is the sphere at point 1 to 2. Now, normal to the surface will be what?
Gradient.
Gradient. Correct. So 3, along the direction normal to the surface, x square plus y square plus z square equal to 9 at point 1 to 2, right? So first of all, I will call this number surface as psi. So let psi is equal to x square plus y square plus z square minus 9 equal to 0. Its normal is del phi, which is given by, sorry, del psi. It is psi. Here also you draw that symbol properly, psi. Otherwise, there will be confusion. So del psi will be dabba psi upon dabba x I cap plus dabba psi upon dabba y j cap plus dabba psi upon dabba z k cap, which is equal to 2x I cap plus 2y j cap plus 2z k cap. Okay, and now this del psi at the point 1 to 2 is equal to 2 I cap, replace x by 1, y by 2, z by 2. It will be 4 I cap plus 4 j cap plus 4 k cap, and therefore the directional derivative along this direction is, sorry, what I have to do first of all, this is the direction we got, right? This is the normal at 1 to 2 we got. So therefore let u bar, so this is our direction, which is 2 I cap plus 4j, direction along the vector k cap, right? Therefore directional derivative is equal to del phi at 1 minus 1 1 dot with u cap, which is equal to I cap minus j cap minus 3k cap dot with 2 I cap plus 4j cap plus 4k cap divided by under square root 4 plus 16 plus 16, which is equal to the root 36, which is 6. Therefore 1 upon 6, 1 upon 6, get the dot product, which is 2 minus 4 minus 12. Correct, no?
Yes, sir. Minus 7 by 3.
Minus 7 by 3 is the directional derivative. See, here I have discussed one case, means in for 1 5 only I am discussing all the 5 cases. Now here what you have to do, you have to take questions from the manual and you have to solve all those questions so that revision of all these directions should happen. Otherwise, if you don't practice properly, then you will not revise at that particular time during the exam what direction we should consider. Okay. Then in the direction parallel to the line,
Sir,
x minus 1 equal to 3 minus y equal to 2z. Yes.
sir, in any case, the DD can it come zero because now I have solved the next and it's coming zero.
ठीक है ना, means there is no slope at particular that particular point. Zero means no increase or decrease. There it is flat over there. Okay. Negative value gives you the steepest decrease. Positive will give you increase, and zero means no change.
Okay, sir.
Fine. Okay. So next is what? Along the line parallel. No, sorry. Along the direction parallel to the line. Along the direction parallel to the line. Along the direction parallel to the line, x minus 1 equal to 3 minus y equal to 2z. Correct? Now, you just recall, is it in the normal, is it in the standard form which I wrote earlier? The standard form was x minus a upon alpha equal to y minus b, sorry, opposite, x minus alpha upon a equal to y minus beta upon b equal to z minus gamma upon c. What I told, the coefficients of x, y, z must be 1, 1, 1. So is it happening here?
No.
No. Okay. So first of all, we have to do that thing. We have to make coefficient of each and every number 1. Coefficient of each and every variable 1. So for that reason, what we need to do, so first of all we will try to express it in the standard form. Okay, so here I am writing that thing. First we express this equation in symmetrical form. This equation in symmetrical form. Okay, for that what I need to do, I will express this as x minus 1 equal to y minus 3 equal to minus y minus 3 equal to 2z. Now, to make the coefficient of z as 1, I will divide throughout by 2, so that it will be x minus 1 upon 2 equal to y minus 3. This minus sign I am taking in denominator equal to z. And z I can write down as z minus 0 divided by 1. Z I can write down it as z minus 0 divided by 1. Okay. So comparing, you don't have to write down this comparing and all in the exam. Just for your understanding, I am writing here. So comparing with x minus alpha upon a equal to y minus beta upon b equal to z minus gamma upon c. The direction ratios of the given line are a b c equal to 2 minus 2 1. A b c equal to 2 minus 2 1, and therefore direction of the line is along the vector u bar is equal to a I cap plus b j cap plus c k cap. The direction ratios will give us the direction of the vector direction of the line along that vector. Okay, so u bar is equal to 2 I cap minus 2j cap plus k cap. So this is the vector along which we wish to calculate the directional derivative. Now you see here what they have given along the direction parallel to the line. We know that if the two lines are parallel, their direction ratios, they are in proportion. So whatever the direction ratios are there for the given line, that is 2 minus 2 1, same direction ratios we can consider for our given direction, and that's why I treated my u bar as ai cap plus bj cap plus ck cap. Everyone understood this what I said just now?
Yes, sir.
Yes, sir.
Vangras?
Yes, sir.
Okay. Other students?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir. Yes, sir.
Good.
Yes,
Thank
sir.
you.
Yes.
So u bar is equal to 2I cap minus 2j cap plus k cap, and therefore the directional derivative, as we got u bar, we will go for finding the directional derivative, which is del phi at 1 minus 1 1 dot with u cap. Do the calculation. So it will give us
1 by
r
3.
I cap minus j cap minus 3k cap dot with 1 by 3 2I cap minus 2j cap plus k cap. Do evaluate. So it will be how much it is?
1 by 3.
1/3.
1/3.
Okay, so it is becoming 1 here, 2 minus minus plus 2 and minus 3. Correct. So this is simply 1 by 3. So directional derivative is equal to 1 by 3 along that line. And finally, the last case, fifth case, along the tangent vector, to the curve, along the tangent vector, to the curve, r bar is equal to t I cap plus 2t minus 1 j cap plus t square k cap. Is it?
Yes, sir.
At t is
Yes, sir.
equal to 1. Yes. So tangent vector is given by tangent vector t bar to the curve r bar is given by to the curve r bar is given by t bar is equal to d r bar upon dt, which is equal to I cap plus 2j
2j
cap
cap plus 2t k cap.
2t k cap, right? And we wish to calculate this t bar at t is equal to 1. So which will be wherever t it is there, we have to replace it. So it will be I cap plus 2j cap plus 2k cap. So let u bar is equal to I cap plus 2j cap plus 2k cap, and therefore go for evaluating directional derivative. So directional derivative is equal to del phi
Minus 7 by 3.
dot with u cap, which is equal to I cap minus j cap minus 3k cap dot with 1 by 3 into I cap plus 2j cap plus 2k cap. So this is equal to minus 7 by 3.
7 by
And
3.
okay, if you take any other point, you will get the other value. Okay, means instead of t equal to 1, if you take t equal to 0, if you take t equal to 2, you will get the other value of this directional derivative. So everyone understood these 5 cases? Any doubt in these 5 cases? I have written example in detail so that although if you refer to it later on, you will understand it properly. Is it?
Yes, no doubt.
Okay. So we'll go to the next example now, different example. Fourth example, right? Or third. Example is if directional derivative of phi equal to ax square y plus by square z plus cz square x at 1 1 1 has maximum magnitude has maximum magnitude 15 has maximum magnitude 15 in the direction has maximum magnitude in the direction parallel to y-axis in the direction parallel to y-axis. Hence find no no hence simply it is maximum has maximum magnitude 15 in the direction parallel to y-axis. Find the values of ABC. Find the values of ABC. Okay, this is the problem. Now read the problem. We have been given the directional derivative of phi equal to x square y plus by square z plus cz square x at 1 1 1 has maximum magnitude 15 in the direction parallel to y-axis. Using this, we wish to find the values of ABC. So first of all, I will write down the given thing. So given surface phi is equal to ax square y plus by square z plus cz square x. Okay. Now we are going to obtain the del phi because directional derivative is been given. Its maximum magnitude is been given. Okay. So first of all, we are going to obtain del phi. So del phi will be formula as I discussed. You have to write down because this is the new example. So delta phi upon delta x I cap plus delta phi upon delta y j cap plus delta phi upon delta z k cap. Okay, which is equal to delta phi upon delta x will be 2axy plus cz square I cap plus delta phi upon delta y. So ax square plus 2byz j cap plus, with respect to z now, so by square plus 2czx k cap. This is our del phi. Evaluate its value at 111. Evaluate its value at 111. It will be 2a plus c I cap plus a plus 2b j cap plus b plus 2c k cap. Okay, so we evaluated the del phi, right? Now what is given in the problem that we have to read it again. We have been given the maximum magnitude of the directional derivative is 15. This thing we have been given, right? Maximum magnitude is 15. What do we know? We know that we know directional derivative is maximum in the direction, in which direction? In the direction of its,
Parallel to y-axis.
no. The fact that we know is what? Directional derivative is maximum in the direction of its normal, right? That is, what is the normal to the any given directional derivative of phi, that I should add. K of phi is maximum in the direction of its normal. In the direction of its normal. And what is the direction of the normal? What is the normal to any given surface phi? It is del phi, right? We know directional derivative of phi is maximum in the direction of its normal, that is del phi. And what is the maximum magnitude?
15.
And maximum magnitude is norm of del phi. And maximum magnitude is norm of del phi. Okay, so therefore, what do we have here? We wish to calculate these values of ABC. So this thing we are knowing. To calculate the values of ABC, we are going to make use of this thing. We are knowing this thing, that direction of maximum, directional derivative of phi is maximum in the direction of its normal, and maximum magnitude is norm of del phi. Okay, so therefore direction of del phi as direction of directional derivative is maximum in the direction of its normal, that is del phi. So what must be direction of del phi? Yes, anyone?
Parallel to the y-axis.
Nana, what is the direction of del phi? Array, what is the direction of any vector?
Unit vector.
Unit vector, na? So as del phi is a vector, what must be its direction? It's unit vector. So del phi cap, okay? So which is given by del phi divided by norm of del phi, correct? Del phi divided by norm of del phi. So what del phi we got? It is 2a plus c I cap plus a plus 2b, a plus 2b j cap plus b plus 2c k cap. Here, if you have not copied this step, here I'm just adding one thing. Please and maximum magnitude is del phi, which is, so norm of del phi is equal to how much they have given, 15. That value I am supposed to replace here. Okay, that I missed to write down there. So this is what last is b plus 2c k cap divided by 15. So I am calling this as 1. Okay, so direction of del phi is this, del phi cap, and also given in the problem what they have given, also given direction of maximum magnitude, is along y-axis, direction of y-axis is what? It is j cap. Do you agree with me?
Yes.
Okay, so therefore, see now both del phi cap is also a direction of maximum change, and y-axis, direction of y-axis is also direction of maximum change. So what do we have? Direction of del phi, so they must be parallel. Therefore, direction of del phi must be equal to direction of y-axis. They must be same. Do you agree with this?
Yes, sir.
Okay, so what do we have? Del phi cap must be equal to j cap. Now, what expression we are having for del phi cap? So I am copying that expression. Okay, so this is equal to j cap. This is equal to j cap. Everyone understood? Now, we have to simplify it further. So 2a plus c I cap plus a plus 2b j cap plus b plus 2c k cap is equal to 15 j cap. I am simplifying this expression. So I am going to write down my RHS as 2a plus c I cap plus a plus 2b j cap plus b plus 2c k cap is equal to 0 I cap plus 15 j cap plus 0 k cap. Now on both the sides we are having vectors with equality sign in between them. Okay, so what should happen? Their corresponding components must be same. Is it?
Yes, sir.
Their corresponding components must be same. Therefore, we have 2a plus c equal to 0, a plus 2b equal to 0, and sorry, 15, not 0, and b plus 2c equal to 0. So what we got? Here we got three equations in three unknowns. So solving them simultaneously, we will get values of a, b, c.
5 by 3, 20 by 3 minus 10 by 3.
Solving them simultaneously, we get what is a,
5 by 3,
b,
20 by 3
and c
minus 10 by 3.
minus 10 by 3. So see, these are the values of a, b, c. These are the values of a, b, c. Everyone got this? Example.
Yes, sir.
Okay. So I'm giving you one example for homework, and we will stop here then. Write down same kind of example for homework. if the directional derivative of phi equal to axy plus byz plus czx at 1, 1, 1 has maximum magnitude for in the direction parallel to the line x minus 3 upon 2 equal to 3 minus y upon 1 equal to 2z minus 2 upon 2. Okay, 2z minus 2 upon 2. Find values of A, B, C. Find values of A, B, C. Okay, so here what you need to do, you need to obtain the del phi, then del phi cap, and you have to equate it to the direction of this given line. Now, first of all, you have to express this line properly in the form of symmetrical line that already we have discussed. You have to make coefficients of x, y, z as 1, and then whatever the denominator you will get, that you have to treat it as ABC. Then you will get that vector, then direction of the line will be the unit vector of u bar. Okay, and then those two you have to equate and you have to solve. Got it?
Yes, sir.
Yes, sir.
Okay, so in the Monday's class, please you tell me answer to this question. Okay, and now please give me attendance. First start with the division 1, roll number 1,
Present, sir.
2, okay, fine. To unmute and mute, it will take much time. I will download the attendance. Okay, is there any doubt in today's topic?
No,
No,
sir.
sir.
Fine.
No, sir.
I will share this PDF with you. Yeah, everyone go through it. You are having now 1 day holiday because you are today full of lectures, online lectures, at least FY3. So you go through this PDF and refer to the examples, solve examples, and try to solve the examples from lab manual. Okay. Fine. Thank you all. I have downloaded attendance. I'm ending this meeting. Thank you.
Thank you, sir.
Thank
Thank
you,
you.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.